This thing has options for that. This cat's about to knock this right. There it went. It's on the floor now, cat. Welcome to episode 2 of TDD and PONG. Just Pong, but it's funner to say it that way. More fun, shouldn't have said funner. Anyway, in this episode, we are going to make the walls. We're going to make the top and the bottom walls, and in the act of doing that, we are going to cover making mocks and spies and stubs for our ball, and then we're going to make an integration test that puts the wall and the ball together, and we watch the scene play out, and we make assertions based off how things interacted with each other. So that is that. Let's get to it. Alright, so we are going to go ahead and make walls, and the first thing we need to do when making the wall is make a test for the wall. First thing we want to do, like we did with the ball, is make sure we can make a wall. So we need a var wall equals load. Nope, scripts wall. So we're going to put the wall there, and then we're going to make function test can make wall. Assert no wall not new, and run it. And yes, so we can't do that. So let's go back over here and touch scripts wall.gd. Run this again, and we passed. We can make a wall. So now we got to do something with our wall. So let's bring up the wall. What's the wall got to do? Well, the main purpose of the wall is that when the ball hits it, the ball's going to bounce. So we need to be able to test this wall with the ball. And what we're going to do is we're going to try mocking out the ball and not actually making it run into the ball, and just making sure that a bounce function does what we expect it to do to the ball. So let's go ahead. We're going to need a ball. Scripts ball.gd. And we are going to assert that okay, so we're gonna expect the wall to take in its bounce method to take in a ball, and then gonna expect that ball to just start going the opposite direction, in the opposite y direction than it used to be. So first thing we need to do is we need a wall. So wall equals wall.new. And we're going to need a ball. But we don't want a real ball, because we're doing unit tests, and we don't want to actually have to worry about setting up a ball. So we're going to mock the ball, and we do the mocking with doubles. So we are going to tell it that we want a double of a ball, of big B ball. And this will give us back something that we can instance, so we just call .new on this. And so now we've got a ball that doesn't do anything. The ball will have all of the same properties and the same methods that exist in a normal ball, but under the covers, when you call that double method, Gut will go off and make a new file somewhere that has all of the same properties and methods as a ball, but it has none of the implementation. So you get an object that looks the same but does nothing. And so what we can do with that is we can use that to verify that we are interacting with an object the way we expect to, without having to worry about that object trying to do things we don't need it to do right now. So when you call a method on a doubled object, Gut will keep track of that, and it will keep track of the parameters that get sent into that. It will keep track of the number of times it's been called and stuff like that. You can also tell Gut that when this method gets called, I want you to return this value, by using the stub method, which we're about to cover. And this gives us a great way to verify that we're interacting with an object without the overhead of the object itself. Yeah, if you are not familiar with stubs and spies and mocks and doubles and everything, The concepts are pretty much the same across different languages. The implementation, of course, will vary, so there's a lot of information out there on the web that you can find. And then, of course, there is the wiki for Gut, which will explain how to use the specific parts. Well, first off, we've got to give the ball a direction. So let's go ahead and stub. This is how we fake out methods. We're going to stub the ball's get direction method so that it returns a specific value. So we're going to stub ball get direction to return. And we're gonna give it a direction, and we're gonna need that later. So I'm gonna put vector 211 that normalized. Earlier we normalized our vectors when we set the direction, but since we're not actually calling the method, we want to go ahead and we're gonna go ahead and normalize it just to keep things consistent. So now we've got a ball that's gonna pass back a direction. We're then going to call wall.bounce ball. And when we call this, we're going to expect that direction, that the wall's going to call set direction and reverse the Y. So we are going to then assert called on ball set direction. And we're going to expect it to get a value of. So we're going to expect this to have inverted it. So let's go ahead and run our tests. And of course, we don't have a bounce method. So our test failed exactly how we expected it to. And when it fails, we get some information back here. We get to see that it expected set direction to have been called on the ball. And it expected it to have had these parameters. But it didn't, that wasn't called on it. It does list any calls that were made that it was able to track. And it only sees that init was called. So now we go back into the wall and, well, let's just go ahead and do ball.setDirection, ball.getDirection times vector 2, 1, -1. And so this should get us exactly what we want. Let's go ahead and run it. And it failed. So it failed. We can see that it did call init. It called get direction. It called set direction. And it looks like these values are matching. That's the problem. We have other options. One of the things that we can do is we can go out and okay, there is the get call parameters method. This method will take in a mocked object and the name of a method, and it will return you the parameters that were sent to it. And you can optionally give it an index, and that allows you to get different instances of calls to that method. So if we had called set direction 10 times, we could say we wanted the third one or the fourth one. And the default is to always give you the most recent call, the latest call, and that's what we want. So we'll just go ahead and go with that. On ball for set direction. We want the most recent one. So instead of making an assertion on whether or not a method was called, we are going to assert that equals params. And this only takes one parameter, so we're going to go with index 0. And we're going to make sure that that guy equals this. And hopefully this one will work. I'm really not sure why, but it gave us an opportunity to demonstrate two different ways of working with stubs. So let's run this, and that passes. Cool. So let's go ahead and see the full output there. And yeah, so in this case, that works. Okay. Well, evidently I don't even know how to use my own tool. I forgot how assert called works. Assert called takes an optional third parameter. And what I mistakenly did the first time was I just put in the parameters here. But the third parameter to assert called expects an array, because there could be more than one parameter to a method. And in order for that all to live in one parameter inside of assert called, we've got to send it an array. So what I should have done was send this in. And so let's watch it fail once, change that to a 0, and rerun this. And there we go. Expected set direction to have been called with parameters. And then if you look closely, there's brackets around here. So now let's change this back to a 1. Run it again, and everything passes. So the next thing we got to do is we've got to make this ball actually interact with the wall. So for that, we're gonna create a set of integration tests, and I could just throw it right in here with the unit test, but let's keep everything organized like this is a real project. So let's go ahead and make a directory test integration. And we're going to touch test integration test. Let's just call it wallin' ball. Doing some wallin' and some ballin'. And we need to set up gut to be able to. So let's check this guy out. Now when we run our tests, we don't see it, because from the first episode we don't have it set up. We only have it set up to see test and not to see, or to see unit and not to see integration. So we've got to go back over to the gut and find the scene. Let's hit you up, and we are going to tell it, we're going to change this directory. We're going to set it to be this current directory. We're going to set it to be test, and we're going to tell it to include subfolders. So now it should find all the tests. So we save that, we run it, and there's our pending test. Good. Okay. So we're going to need a scene now. We're going to need a wall scene that we're going to create, and let's go ahead and make that. Let's make a new scene. We are going to make it an area 2D. We're going to call it wall. And we're going to give it a shape. It needs a shape. Collision shape. We will rename you to shape. And we are going to set the shape to be a rectangle. Okay, we've got our rectangle. Let's go ahead and make it a little bigger. Save you off into scenes. And now we've got a wall scene. So let's get over here, and we're going to make our wall. Now we got to set the ball moving towards the wall. So we're going to do a ball dot set direction. 0, 1. It's going to go straight up. Now we got to let this whole scene play out. We need that ball to move towards the wall. We need the ball to hit the wall and then to come back down. So in order to do that, we're going to yield. And Gut has some tools for yielding. There's a yield 4 and a yield 2. Yield 2 will allow you to yield to a signal and a time limit. And so that way, if the signal doesn't fire off in a certain time, things will continue. That can be real helpful. Here we don't have a signal to hook up to, so we're just going to use yield 4, which is just yielding for a certain amount of time. And we're going to say 5 seconds. And The oddity here is that because of the way yield work, yield needs a signal name, and when you use yield 4 or yield 2, gut emits a certain signal, and the name of that signal is held in a constant called yield, which you get when you inherit from test.gd. So what we should see here, we've got no asserts, but we're going to go ahead and watch this run. So let's run our tests. Oh, nope. Let's go back over to tests. Let's run our tests. And cool. There's the ball sitting there doing nothing, and we can't see our wall. Perfect. I think we need to make our wall visible. We can do that the way we did the old way with visible collision shapes. We could run this again. And okay, so we've got it set up. We can see that the ball here is underneath the wall, and if it did move with a speed of 50, we should see it now. Oh, nope, not 50. Or no, is 50, but we need its direction to be -1. All right, there it goes, and it goes right through it. Perfect. Test should fail. So what do we want to see? We want to see that after we've yielded, we want to assert greater than. We want ball.get direction y is greater than 0. So after this gets done, we would expect this to have a direction greater than 0. Let's go ahead and make this 100. And I don't want to yield for that long. Run it again. 1, 2. Done. Okay. -1 expected to be greater than 0, and it's not. So we've got a failing test. We can watch it go. Let's go over to the wall. What do we need to do with this wall? Go over to the node. Area entered. That should work. Let's connect. Oh, he doesn't have a script yet. That might be another reason why nothing would work. So let's go ahead, set the script. Alright, and if we run our tests again, it's still going to fail because, oh, it's not a thing. Area 2D. Now run our tests again. Still going to fail because we've got a bounce method, but it's not wired up to anything. So we come back over here to the wall. We look at the node. Area entered. Let's go ahead and connect that. And we're just going to call bounce on the area that comes in. And now when we run it, now when we run our tests, boom, we got a bounce. We now got a bouncing wall ball combination that is fully tested. Let's run it again one more time. Look at that. It bounces. Neat. Okay, let's put a little polish on this and put some of these pieces together. I want my wall to have a color. We need to be able to draw the wall. And I've got this handy dandy little thing that I made earlier that I'm going to paste in right here. Call this shape. And we got a color. Let's make color 1, 1, and 1. Now, when we run our test, we should have, yeah, we got a white wall. We can go ahead and turn this off. Run it again. There it is. Nice white wall. I want to be able to set that that color though. So let's go ahead and run our tests and should have a method. Yep, those fail. Okay. Let's go over to wall. Let's go back here. Let's use this guy again. And just in case you didn't see it in the first one, the magic here is just a little bash function that I got, which will create accessors, accessor text, and it prints it out and also copies it to the clipboard on the Mac. Everywhere else, I think it would just print. So now we've got our get and our set color. We need a function or a variable. And we are expecting the default to be white. So now if we run our tests, yep, everything's passing. Okay. But we want to go ahead and use the color down here. So let's go ahead and put color there. And you know what? It would be nice if we could just set this in the editor. So let's go ahead and do that. Set color. Get color. So now, let's go open up our game. Let's open up the game. And we've got a ball. Let's go ahead and also let's add some walls in here. Nope, not to you, to there. And let's duplicate you. And we'll call you top wall. And we'll call you bottom wall. There we go. There we go. And yeah, let's set top wall to red. And let's make bottom wall green. And then run it. There we go. Ball's going the wrong way though. Let's watch these balls and walls interact the way we'd expect them to. We're in game. Let's look at the game script. Yeah, we'll set this to 0, this to 1. Run it. Ah, and it's bouncing up and down between the red and the green walls, and we've got a lot of what makes a Pong game together. All right, stay tuned for the next episode where we will start paddling. And we'll get the paddles out, and we'll use the paddles and the wall, and we'll have a whole game. And that's that. Thanks for watching, everybody. I'll catch you next time.